Okay, guys. So, what I'm thinking is going on here, guys, is the following. We are drive our car 20 meters per second. So if I just do the car as UVAST in red, the car is going at 20, and the what's it? Sees a second car. So we call it car A and car B with respective colors, blue and red. Okay. Okay. Their time frame's the same, isn't it? Because of so it has to slow down to the same speed as the car in front. So everybody happy with 20 to A? Okay. We don't know the A value because that is the goal of the question. Goal of the question is find the A value. The S value now, this is it, okay? So if you imagine that the blue car covers a distance X, yeah? The red car has to cover the same distance with an extra 100 and another 120 on top. So we call that X plus 120. Just so it's basically just about to collide. The other car has a speed of 8, final speed of 8, and a velocity of 0. The times are the same in both of them. The t values are just t. So my recommendation is what links the two sets together is the x values. The x values link both sets together. That implies I should use an equation regarding s. So I should use an s equation. I can either use phi squared equals u squared plus 2as, or I can use s equals ut plus a half at squared. What would be your choice? Really? So, believe it or not, if you use the blue data, if you do phi squared equals u squared plus 2as using the blue data, it's going to make it abundantly clear you shouldn't use it. Because guess what happens? 8 squared equals 8 squared plus 2 times 0 times x. Oh, really? 64 equals 64. Thanks. Good to know. No new information gained, right? Would you agree? So that was a bit of a dud for us there. So the t values are the same, which means you can relate one equation to the other. So I'd be inclined to go for s equals ut plus a half at squared, and then do it for both equations. So let's say s, which is x plus 20, equals 20t plus a half at squared. Everybody see x plus 20 is 20t plus a half at squared?
Sorry, isn't it x plus 120?
Huh?
Isn't it x
Oh, x plus 120. Thank you. Whoop. X plus 120. Now, I'll go down and do the other one. The blue data set. So, x equals ut, which is at plus a half at squared, but a is 0, isn't it? So, what can I say about x then? X equals? No, at. So what does this x here equal? Sub it in. We should be good to go in a second. At plus 0. Because the when you do a half at squared, the a value is 0, which results in a half at squared being equal to 0. Okay. So now what I think I'm going to say next is, I think I'm going to say that at plus 120 is equivalent to 20t plus a half at squared. Ever got that? All right. How many equations do I have? How many equations do I currently have? I had 3, but I sort of, well, I made the third one by putting 2 of them together, didn't I? I had the 2 distance values, and I put them, I subbed them out for the x value. Now, I'm currently at this line here. How many variables do I have? I have t and I have a. Any ideas how do I get rid of that?
V equals UT.
Same thing as last time. V equals U plus AT. For which data set, the blue or the red? The blue. Here we go again. 8 equals 8 plus 0 times t. 8 equals 8. So, not that one. Which one is it? The red, okay?
Because I have it labeled blue in this one.
Ah, okay, okay. Can I use distance, speed, time? And what I want you to remember is it actually does use distance, speed, time. Because think about this. You can use dst when your acceleration is 0, right? And what happens to the half at squared when it's 0? The half at squared essentially disappears. What does S stand for? Distance. What does U stand for? Speed. What does T stand for? Time. You are using distance equals speed times time. You just aren't even aware of it. Is that right? There you go. Now, back to this. Phi equals U plus AT. Okay. Phi is 20. Oh, no, phi is not 20. Phi is 8. U is 20 and AT. Now, I'm about to say plus AT because we know A is going to be negative in a minute, don't we? Minus 12 equals AT. I suppose I'm going to do it my lazy way again. What was the lazy way I did it last time? Oh, stop doing that. What did I do to AT squared last time? I turned it into AT multiplied by T. It's the same thing as AT squared, isn't it? And what can I replace AT with? Minus 12. What's half of minus 12? Minus 6t, yeah? And now we have it. We're in the end game now, I think. I think what I'm going to get is 14t on the right. I'm going to bring the 8t over and take it away from that. I'm going to get 6t, leave the 120 where it is. T value of 20. Yeah. Right. So, haven't answered the question. The goal of the question was to find the deceleration. I'm going to use this equation up here. What am I going to do? Acceleration equals minus 12 over. Acceleration equals minus 12 over 20. Acceleration therefore equals minus 3 over 5. ms squared or ms minus 2. Whichever one takes your fancy. Occasionally I'm wrong, but not most parts. Okay. Now, so we had that there, didn't we? Now, what's it telling us this time? It's using an A value of 1. Okay. And how long does it take to get 66 meters behind the slower car? Now let's think about this. Yes. Oh, thank you. Yeah, it's a deceleration, so thanks very much for that. It is minus 1. Okay. Tell me something. What do I have to change here? 20. Okay. I don't think we're going to reach 8. Do you? Why are we not going to reach 8? We're not getting right up the car. We're actually just getting a distance of behind it. Yeah. So that V value's gone. No dice. Agreed? Would you also agree that the time is the same as it's not? Sorry, the T values are the same, but they're not the same answer as last time. Is that all right? Now here's the yes, sir. That's exactly what you're meant to do. Well done. Excellent work. So what he is saying is that you were 120 meters behind. Agreed? Would you agree to start that A is 120 meters behind B? And then at the end of this question, how far are you meant to be behind? 66. Okay. So how much extra distance did A travel in comparison to B? Huh? It traveled an extra 54 meters. So what we're saying is you can set this up two ways. You can say distance covered by A minus distance covered by B is 54. Or you could claim the distance covered by A is the same as the distance covered by B plus 54. It's your choice. So I could call that X, and I can call this one X plus 54. Does that make sense? Because A covers 54 extra meters. Okay? Sorry, give me a second. My head's about to explode now. Yeah, thanks. Sorry, guys. Uh, the car that's catching has to travel the bigger distance. So SA is the second one plus 54. So that's X plus 54, and that's X. Thank you. Okay, need a software update. All right, guys, off you go. Try and finish that off now yourselves. The red data set, we're going to say that X plus 54 equals UT, which is 20 times T minus a half times minus half times 1. So I just changed it into minus a half T squared. Blue data set results in X being equal to 8T plus a half AT squared, which is 0. I underline the X value on the left here. I say, do you know what, pal? You are going to turn into an AT. You have no choice in the matter. Here you go. You're now AT. And then we're going to get a quadratic, I think. So I'm going to bring over the half T squared onto this side. I'm going to bring the 20T over to the 8T to make it minus 12T. And I don't like fractions. They don't like me. I'm going to multiply everything by 2. Now, I think we might have the minus B form of this, do we? Or is there good factors here? 4 and 27 ain't going to cut it. Okay, so